one doesn't belong? Who wants to tell me? What?
The whale because it's not man-made.
Okay, so you say the whale because it's not man-made. Okay, anybody else? Okay, so something because it is the largest in weight. Okay, Libby?
Titanic because it's swimming in the space specifically.
Oh, I see. I see. It has a specific name, Titanic versus like just a bell, a submarine, a whale. Okay, these are really good. Anybody else? Something different? Oh, okay. A bell because that is one in water. I like it. Anything else?
Bell because it's the lightest.
Okay, it could be the, yeah, it is the lightest according to the numbers there. Anything else? These are all good answers. You could say the Titanic because it's the one that remains something. Still in the ocean, something. I don't know. All right. Okay, we're gonna come back to that. All right. Today we are going to talk about scientific notation, and I have a brain pop to try to jazz it up a bit. Jazz it up. Exactly. So scientific notation is a shorthand way of writing really big or really small numbers. Okay? Scientific notation is written as a product of two numbers. What does product mean? When you multiply. Product is when you multiply. The first number must be between what? What do you say? 1 and 10. And then the second number must be a, what do you think there? Of 10. Power of 10. Okay? All right. So what we're going to do, we're going to go from standard to scientific. We're going to go through the directions and actually do this one down here at the same time. Okay? So first you're going to create a number between 1 and 10 by moving the decimal. Okay, so in this example right here, where would I put my decimal? Behind the 1850 what? Behind the 1. So that's going to be 1.85. Okay, and I don't need to put all those zeros, right? Because it's just a bunch of zeros. Zeros at the end don't matter. So did I create a number that's between 1 and 10? Yes. Okay. Number 2, count the number of times that you moved the decimal. This number will be your blank of 10. Power, that's right. Okay, and so the way I do this is I see where was the decimal originally. It was at the end, correct? So I moved it 1, 2, 3, 4, 5, 6 places. So that becomes my power of 10. So that's going to be times 10 to the 6. So the number of bumps that I did becomes my exponent. Okay? If your number is really large, the exponent will be positive or negative? Positive. And if your number is really small, like a decimal, then the exponent will be negative. Another rule of thumb is if the number was really really large, we moved the decimal which way? To the left. Okay? Then that means we're going to have a positive exponent. And here we moved, if it's small, we're moving the decimal to the right, then you're going to have a negative. All right, so you guys want to try one? How about you try number 2 on your own and pause the video. Yeah. Did you guys get 4.2 times 10 to the 4? Yeah. Now let's do a small one. Okay. So up here, where's my decimal going to end up? Behind the 7. That's exactly right. Okay. It goes behind the first non-zero whole number. Okay. So that's going to be 7.826 times 10 to the, and it was here. I'm going to pick it up. 1, 2, 3. I moved it 3 times. But that would be 10 to the negative third, okay, because I moved my decimal. number, okay? You guys try number 4 on your own. Did you guys get 1 times 10 to the negative 5? Yes. Okay, guys, questions? Pretty easy. Yeah. Okay, so that's going from standard to scientific. Now we want to go the other way. We have scientific, and now we need to go back to standard. Okay? All right. It says move the decimal the same number of places as the, what do you think goes there? Exponent. If the exponent is positive, you're going to move the decimal to the blank in order to make it blank. Okay, so hey, think about this for just a second. If my exponent, let's just say, is positive, is that a big number or a small number? A big number. So if I want to make the number 3 bigger, I need to move it to the what? Right, yeah, because I need to make it bigger. And then if the exponent is negative, then you're going to move the decimal to the left in order to make the number smaller. So again, if I have 3 times 10 to the negative third, then that tells you that's a really small number, right? Okay, so now let's do it. So we have 7.83 times 10 to the 7. Okay. Unlike when we did it before, they had all those extra zeros. I don't have enough space here, so the first thing I'm going to do is rewrite it down here where I've got some space. Okay? And I'm doing times 10 to the 7. So this tells me it's getting bigger, so I'm going to move my decimal to the right. How many times? 7. So we're actually going to, I show the bumps. 7 times. 1, 2, 3, 4, 5, 6, 7. And then, what goes in all those little bumps? Zeros. I know it might seem silly, but guess who never gets their scientific notation questions wrong? This girl. I'm just saying. It looks silly, but I don't ever get it wrong. Okay? Now, when I rewrite it, I should put my what? I don't have any. Well, I could put a decimal, but what else do I need? Commas. I know I'm going to put a comma here and a comma here and rewrite it normal. 78,300,000. When you rewrite it, you'll want to rewrite it without those bumps because that's like showing your work. Okay? Let's do another one. Let's come down here. 8.345 times 10 to the negative, is that a 5 or 6? 6. Okay. So I'm going to, again, I'm rewriting my number down here where I've got space to work. Because my decimal is negative, that tells me that's going to be what kind of a number? Really small, so I'm going to move my decimal to the left. How many? 6. 1, 2, 3, 4, 5, 6 decimal. And then what goes in all those bumps? Zeros. See, same thing. Okay, and then you can just rewrite it so that it's pretty. You can put an extra 0 out front like we're used to seeing, but just don't get confused with these zeros, okay? All right. Okay, how about you guys do number 2 and number 4 on your own? If you're home, pause the video. Okay, so on 2.5 times 10 to the 4th, I know I'm getting bigger. 1, 2, 3, 4. So that would be 25,000. Do you guys get that? And then 3. Where's the decimal in 3? It's at the end. So remember, when you don't see a decimal, it goes at the end, and then to the negative 3, that means it's small. I'll go on left. 1, 2, 3. So 0.003 or 0.003. Both of those are okay. Y'all get those? Okay, so now there's a table down here where they want you to fill in. If they gave you standard, do scientific. If they gave you scientific, go back and do standard. Okay? Pause the video. All right, guys, check your answers. Show me what I got. I got 5.82 times 10 to the 6th. Yes. 425,000. 1.2 times 10 to the 3rd. 0.6 zeros, and then 6257. And then 1.5 times 10 to the negative 3. You guys get that? Okay, so now it says, let's go back to the warm-up and convert each one of these weights to scientific notation. Did you wonder why they also included weights over here in our warm-up? Okay, so let's do the whale. So what would the whale be? 3.3. 1, 2, 3, 4, 5. Okay. What about this one? And y'all see shortcuts? 3, 6, 7. Y'all see that? Good. And then what about the bell? 3, 4, 5. Be careful. And then this one would be 9.6 times 10 to the 3, 6, 7. Okay, we're good? All right. So now I have a. So if you will grab a device, and the back page is your